Welcome to The Explainer, everyone. I am so thrilled to have you here today. We're going on a really fascinating journey into the world of net DevOps. But instead of just floating around in abstract cloud theory, we are going to ground this in reality. We're going to trace the complete end-to-end life of a single, humble VLAN. We'll track it from its very inception as just an idea in someone's head, all the way to a fully automated reality running seamlessly across your network infrastructure. So let's dive right in. There's this classic IT proverb that says, if you have to do it twice, you should automate it. And honestly, that hits incredibly close to home for network engineers today. We all know the drill, right? Logging into account after account, jumping from console to console just to spin up basic resources. But as businesses demand more and more agility, scaling our operations means we absolutely positively have to move away from manual console configuration. It just doesn't scale. So here's our roadmap for the explainer today. We'll be hitting the net DevOps transition, how to plan, write, and store your code, reviewing and testing, deploying and validating, maintaining and handling failures, and wrapping up with your immutable network future. Starting with Section 1, the net DevOps transition, moving from manual drudgery to automated scale.
Think about the number 43 for a second. Why does this specific number matter? Well, think about a really simple task, something like a 1-minute manual virtual machine or VLAN launch. If a 100-person team executes that just once daily, it wastes 43 hours a year. That is an entire work week gone, literally just clicking buttons. When your user base scales from, say, 10,000 to 100,000, you just can't rely on an army of IT managers furiously clicking through web interfaces. This brilliantly illustrates the massive, undeniable return on investment you get from taking the time to code your infrastructure up front.
To really wrap our heads around how we actually write this automation code, let's look at this cake analogy to compare the two main approaches. On one side, we have the imperative model, which uses tools like Chef or Ansible. This is kind of like writing a detailed, step-by-step recipe for a kitchen assistant. You are controlling every single granular action needed to bake your chocolate cake. But on the other side, we have the declarative model, using tools like Terraform. This is like simply ordering a chocolate cake from a master chef. You just declare the final state you want, the what, and you trust the tool to figure out all the messy how of actually deploying it. All right, moving on to Section 2, plan, write, and store. Kicking off the VLAN journey. This is where the magic starts. And I want to be clear, this isn't just cowboy scripting. It's a highly controlled workflow. Step 1 of our 8-step lifecycle is plan. Here, we identify the scope, dependencies, and exactly how we're going to validate this new VLAN. Step 2, we write. We define the infrastructure using structured languages like YAML, JSON, or HashiCorp configuration language, and we lean heavily on reusable templates for consistency. Step 3 is store. We save these definitions in a version control system like Git, making sure we use a separate working branch. And finally, Step 4 is review, where we create a call request. The crucial takeaway here is that writing the code is just one small step in a much safer, broader process.
So let's officially define what we're talking about. Infrastructure as code, or IAC, is managing the foundational layers of an IT system entirely through machine-readable definition files and controlled lifecycles, rather than physical hardware configuration or manual interactive tools. Ultimately, we are treating our infrastructure exactly the way a developer treats application software. We're standardizing how we interact with our entire network stack. Which brings us to Section 3, review and test code. This is all about collaboration and validation before launch. Now, during a pull request, there is a very strict division of labor. You have the developer proposing the VLAN changes, you have the reviewer who actively checks for errors and confirms the code actually meets network standards, but I want you to look at that third row. The automation tool, something like Atlantis. This is vital. These tools can automatically run plans to show what will happen, and critically, they lock the state. This means while you are busy updating the VLAN, no one else can deploy conflicting changes. It completely prevents those massive overlapping configuration nightmares. But wait, before we hit that approve button, we have to test. We do syntax validation to catch any silly typos. We check for compliance with our security policies. We might even test the whole thing in a virtual lab environment. And best of all, we can run a dry run or check mode preview. This is an incredibly powerful feature that allows you to preview the exact expected changes without actually applying a single thing to your live production network. It's all about shifting left, finding the errors early in the process before they bite you. Okay, Section 4, deploy and validate changes. We are pushing our VLAN to production.
We are now in the home stretch of our 8-step life cycle. Step 5 was test, which we just covered with our dry runs. Now for step 6, we deploy. We push the changes via automated pipelines, maybe rolling them out gradually across groups of devices. Next, step 7, we validate. We check the actual state of the physical network against what we intended in our code. And finally, step 8, we maintain. We continuously monitor everything to correct any configuration drift. This right here is exactly how that humble VLAN successfully becomes an active, monitored entity on your network. Now listen closely on this one, because a deployment is never truly complete just because your automation tool flashed a green success message. You absolutely must validate. You need to log in or use verification scripts to confirm the configuration actually exists on the device, check the interface and routing statuses, actually test the active network connectivity, review the automation logs, and please, make sure you didn't accidentally break existing services. Only when these specific checks pass is the job truly done. Next up is Section 5, Maintain and Handle Failures. Basically, what happens when things inevitably go wrong. I want to pause here for a massive reality check. Does a git revert automatically undo a network change? Just take a second to really think about that. Because there is a very common and frankly highly dangerous misconception out there that simply clicking revert commit in your version control will magically unconfigure a physical switch. Well, spoiler alert, the answer is a resounding no. You see, a git revert just changes a text file in a repository. It doesn't automatically reach out and undo hardware state. When things fail, and they will, you have to use a deliberate recovery process. As we've outlined here, first, you immediately stop any further automated changes. You identify the specific failed task or device. You check if partial changes were applied, like did half the site get the new VLAN and the other half didn't? Then you correct the underlying infrastructure code. And finally, you must apply a completely separate, fully tested manual rollback plan. You cannot skip this. And finally, Section 6, your immutable network future. Embracing a brand new paradigm. This is the holy grail right here, immutability. In a truly immutable infrastructure, once something is deployed, it is never modified in place. If you need a fix or an update, you don't patch the live running system. Instead, you deploy a completely new, updated version of the infrastructure to replace the old one, and then you decommission the old one. It sounds radical, but it allows you to track your versions perfectly and prevents all sorts of headaches. But to pull that off, you need to adopt one non-negotiable rule. Your repository is the single source of truth. Direct manual changes must be strictly avoided, period. If a rogue engineer logs into a console at 2 a.m. to manually tweak a setting, they are creating dangerous configuration drift. The code no longer matches reality. Basically, if it isn't in the code, it shouldn't exist, because those out-of-band changes will absolutely cause your automation to crash and burn the next time it runs. So as we wrap up this explainer, I want to leave you with this final provocative question. Your code is the source of truth, but is your team actually ready to let go of the console? It is a massive cultural shift to stop making manual tweaks and fully trust your automated pipelines, but I promise you the reward is incredible speed, effortless scale, and unparalleled reliability. Thank you so much for hanging out with me today. I really hope you walk away ready to take total control of your infrastructure lifecycle.